We are going to be discussing the formation of acid halides, anhydrides, esters, and amides. First, we're going to do the formation of acid halides of the carboxylic acid and SOCl2, which looks like this, as a sulfur with a double bond to an oxygen and two single bonds to chlorine. First thing to do is ask who has electrons and who wants them. The oxygen on the carboxylic acid has electrons and the sulfur wants them, and it'll push the bond out onto oxygen to form our intermediate with a positive charge on oxygen and then a negative charge on this oxygen. And then this negative charge on this oxygen is going to come back up to form a bond with the sulfur and then push a chlorine ion off. Next, a chlorine ion is going to come in and deprotonate this oxygen to get rid of the positive charge. And then this creates a good leaving group. Again, we have to ask ourselves who wants electrons and who has them. In this case, this chlorine wants electrons, and this oxygen has them, pushing that bond off onto oxygen and forming a new bond to chlorine, giving the oxygen a negative charge. Next, the negative charge on this oxygen is going to come back to form a bond with the carbon, pushing this leaving group off, giving you the final product of the acid halide. Next, we're going to do the formation of anhydrides. This is done by reacting two carboxylic acids together in heat. We have to ask ourselves who has electrons and who wants them. This oxygen here has the electrons, and this carbon here wants them, pushing this oxygen bond off. Now, you could have done this the other way too, but I just chose to do it this way. And this will form your intermediate. Next, the electrons on this oxygen are going to come and deprotonate this oxygen, getting rid of the positive charge. The next thing that will happen is the negative charge on this oxygen is going to come back to form a double bond with the carbon and push the water molecule off to form your final product of the anhydride. Next, we're going to do the formation of esters. We need to ask ourselves who has electrons and who wants them. This oxygen double bond to the carbon has electrons, and this hydrogen here wants them. Again, we have to ask ourselves who has electrons and who wants them. The oxygen on the propanol has the electrons, and the carbon wants them, and it's going to push this bond up, getting rid of the positive charge on the oxygen. The next thing that will happen is the electrons on this oxygen are going to come and deprotonate this one to get rid of the positive charge. That created a good leaving group of water, which will then leave to get rid of the positive charge on that oxygen. The water that then just left is going to come back to deprotonate the alcohol to form a double bond to the carbon, which will then give you your final product of the ester. Next, we're going to do the formation of amides. This is done by reacting carboxylic acid with DCC, which is a six-membered ring bonded to nitrogen, double bonded to a carbon, double bonded to a nitrogen, which is then bonded to another six-membered ring. We need to ask ourselves who has electrons and who wants them. The oxygen on this alcohol has electrons, and the carbon wants them, pushing a bond off onto nitrogen. This then forms our intermediate. The negative charge on this nitrogen is going to then come deprotonate this alcohol, or this oxygen, to get rid of the positive charge. And NH3 is then going to come attack this carbon because it has electrons and the carbon wants them, pushing this bond off onto oxygen to form our intermediate with the NH3 bonded to the molecule. The negative charge on this oxygen is going to come back to form a double bond with the carbon, pushing this leaving group off, forming a double bond between the oxygen and the carbon, and pushing that bond between the carbon and the nitrogen onto the nitrogen. The negative charge on the nitrogen on the leaving group is then going to come deprotonate the NH3, getting rid of the positive charge, leaving you with your final product of the imide.